Boldly going where no science show has gone before. The Naked Scientists.
Hello and welcome to The Naked Scientist with me, Dr. Cat, and with Ben Valsler.
Hello.
And this week we are looking into the science of the mind. In particular, and this is great, the psychology of drinking and dancing, two of my favourite hobbies. Orange squash, obviously. We will be finding out why an alcoholic drink can make people look more attractive and how a cigarette may have the same effect but probably makes you smell worse. We'll also be finding out what your dance moves may say about your genes and your potential as a parent.
Plus, on a slightly more serious note, we'll be finding out what happens inside the minds of people suffering from post-traumatic stress disorder.
It's almost like having a library with a good, well-ordered librarian, the hippocampus, or there's this maniac who just keeps dashing in and getting the books and shoving them under your nose. You've got to read them, and that is PTSD.
And we'll be finding out how scientists can now selectively wipe your memories, how sticky tape may be a source of X-rays, and why the stinky gas in rotten eggs and in those nasty farts could also be good for your health. Ben?
Anyway, in Kitchen Science, Dave will be showing me how to see the world from a different perspective with the help of a rather fetching pair of goggles. More about that later on.
You do have some nice specs, Ben, not those ones.
No, these were much different.
Trendier than Sarah Palin. That is all to come on today's Naked Scientists. If you want to get in touch with any questions or comments, we would love to hear from you. Our email address is chris@thenakedscientist.com.
The Naked Scientist Podcast. Powered by UK Fast, the UK's best hosting provider. On the web at ukfast.net.
Now, no longer the domain of science fiction, researchers at Medical College of Georgia in the US have found a way to selectively wipe memories from the brain. This is brainwashing, yes. Luckily, so far, they've only got this working in mice, which is a relief for us all. They can't carry out their evil plan. It all centres on a molecule called calmodulin-dependent protein kinase 2, or CAMK2, and this plays a really important role in many aspects of learning and memory. And writing in the journal Neuron this week, Dr. Joe Tsien and his team described their experiments in which they've rapidly change the levels of CAMK2 activity in the brains of genetically modified mice. And these mice had been engineered so that you could just give them a simple chemical and it would change the levels of this molecule up in their brains. Now, the scientists found that temporarily boosting levels of this protein, CAMK2, it affected whether mice could remember newly formed memories, and even it affected whether they could remember fear from a month before. And further experiments showed that this wasn't due to the fact that mice couldn't recall those memories or any other type of memories, but they'd specifically managed to wipe those memories. Now, if the name of Dr. Tsien seems familiar to any of you science junkies out there, it may be because back in 1999, he and his team created Doogie. This was a mouse that had enhanced learning and memory skills. And although this current experiment may sound like the work of evil scientists, their brain-wiping research could actually be very helpful in the future. For example, you could selectively wipe really traumatic memories or get rid of phobias. However, Dr. Tsien does say that we shouldn't expect human brainwashing anytime soon. And he says, and I quote, "No one should expect to have a pill to do the same in humans anytime soon. We are at the foot of a very, very tall mountain."
But a very exciting mountain to climb.
Very exciting. I could wipe all my terror away. That'd be great.
Also, this week, researchers have found X-rays generated from a very unlikely source, a roll of sticky tape. By putting the roll of tape in a vacuum chamber and unrolling it with a motor at a rate of about 3 or 4 centimetres per second, not only did they register that there were X-rays present, but they actually did produce enough X-rays to get an accurate X-ray picture of their finger.
So, hang on, they've put a roll of sellotape in a vacuum tube and they go zip, and it gives out X-rays?
Yes. Shocking, isn't it?
What on earth were they doing to find this out? What does it mean?
They're looking into quite a well-known phenomenon called a triboluminescence. And actually you can see this with sticky tape in the dark. This is almost a kitchen science experiment in itself.
Oh, with envelopes and stuff like that.
Envelopes
yeah.
are a very good example. It also works with certain sweets as well. When you bite into them, you can see them flash. But writing in the journal Nature, Carlos Camara and his colleagues at UCLA describe how they made the discovery while looking into triboluminescence. And he said that you can see these things, and so nobody thought that it would be a problem to get radiation from them, because light, of course, is a type of radiation. But people were very surprised when they get powerful forms of light, like X-rays. Now, triboluminescence occurs in the sticky tape when the glue is pulled away from the underlying tape layer. The molecules get sort of stretched out, and this separates all the different electrical charges in the adhesive. And as they're pulled further apart, the voltage, or the potential difference between these charges, increases to the point where it actually overcomes the natural resistance of the material, and you get a discharge from it, an electrical discharge.
So the electricity kind of pings back across this difference.
It jumps across, producing basically a mini lightning bolt from that. So when you do that in air, you get visible light. So again, a little kitchen science for you. Turn off all your lights, grab a roll of sellotape, unroll it quite quickly. You should see a sort of slightly blue glow coming off it. Now, the other thing that was really interesting about this was that when you unwind it in a vacuum, the electrons that do that discharge, that make that little jump, don't have any air molecules in the way to slow them down. So when they slam back into the tape surface, they decelerate so very quickly that all of their energy gets turned into a short, vigorous burst of X-rays, which was strong enough to X-ray their fingers. Now, nobody's suggesting that instead of actually putting people in a current X-ray machine to check broken bones and so on,
wrap them in sticky tape.
Wrap them in sticky tape and suck out all the air. But it does a very interesting breakthrough, and it does represent the most compact and lightweight way yet discovered to produce X-ray light. Carlos said that this could have all kinds of applications for portable X-ray production in cameras and other imaging devices, so it's very promising.
I think that's fantastic. I just love, they're sitting in the pub. I'll tell you what, boys, let's get that sellotape and put it in a vacuum. That'll be funny. Anyway, on to a completely different subject now. You must have heard this saying, Ben, he who smelt it dealt it.
I have, yes.
Yes, we're all familiar with that. It's when someone releases an unpleasant odour from their back end, and that's that whiff of rotten eggs. And this is actually a gas called hydrogen sulfide at work here. But actually now a team of researchers has shown that this rather whiffy gas plays a really important role in controlling your blood pressure, and it's produced by cells that line the blood vessels. And the scientists found that hydrogen sulfide made in your body, like in your blood cells, can relax blood vessels, dropping the blood pressure. This is a good thing. And to find the link, the researchers studied mice that were lacking the gene that codes for an enzyme called CSE. And this is the enzyme that makes hydrogen sulfide in the body. And they measured the levels of gas in the tissues of these mice and, rather unsurprisingly, found that they had very low levels of hydrogen sulfide. And then they put tiny little blood pressure cuffs on the mouse's tails to measure their blood pressure, and found that it was actually around a fifth higher, 20% higher, in these mice with no CSE than normal mice. And this showed they had seriously high blood pressure, hypertension. And they also found that their blood vessels from these mice hardly relaxed at all when other drugs were given to them that normally does relax blood vessels. Now, so far this work has only been done in mice, but it is highly likely that it's at work in humans as well. And if this sounds rather familiar, it's because we've known for some time that we also produce a gas in our bodies called nitric oxide, NO. And we produce this gas and it also helps to relax our blood vessels. So this is another gas molecule, a gas transmitter in our bodies that's having this effect. And drugs that affect nitric oxide production are already in use, and our listeners may have heard of one of those. It's Viagra, which is rather more famous for its side effects than its actual effects on the blood circulation. But now we've discovered this hydrogen sulfide pathway, it does open a new door for kind of new types of treatment for hypertension, so it's quite exciting, if a little bit smelly.
Yes, does this mean that really mean trick you can play when you're in bed with your partner and you break wind and then quickly pull the covers up over their head is actually good for them?
I think it's only these tiny, tiny quantities of hydrogen sulfide produced deep within the blood vessels. No, you're just horrible.
I wouldn't dream of doing it myself. I've merely heard that my friends have done it in the past.
Yes.
Yes, perhaps. Well, doctors have also developed a new technique with which to tackle one of the more embarrassing aspects of sexually transmitted infections. Now, at the moment, when a patient is diagnosed with any STI, there follows a laborious contract tracing process. This is where you have to track down, warn, test, and then treat any recent sexual partners who might also be at risk. It's very time-consuming, it's a very costly exercise, but it's absolutely critical from a public health perspective that you try and catch all of the people who are potentially infected before they then go on to infect others. Now, many patients find this very embarrassing, and understandably, I think it's not a pleasant phone call to have to make to an ex-partner or to a one-night stand.
You bet.
Now, writing the journal PLOS Medicine, Deb Levine and her colleagues from the Internet Sexuality Information Services, they present the electronic answer to this situation, a system of anonymous e-postcards that alert recipients to what they might have picked up, say, at a recent party. Their web-based initiative is called InSpot, which stands for the Internet Notification Service for Partner partners or tricks. And it's a website with a difference. Users choose from a range of online greetings cards, so rather than happy birthday, happy Christmas...
Hello, you might have chlamydia.
Yes, exactly. It's not as pleasant a card to receive, perhaps, as happy birthday, but it's still a very important one. Now, it does also mean that people can add a short message, but it's sent, and this is the real trick to it, it's sent anonymously, so you don't actually have to say who you are. Now, you add a little message... The thing gets sent out, this e-card gets sent out, you receive it in your inbox, and it gives you links to information about the disease you might have caught or might be carrying, and a list of the nearest places to you to seek treatment or advice. So it is very helpful for stopping these things before they get too far. The system was actually first launched in San Francisco back in 2004, and since then nearly 50,000 e-cards have been sent, and they've scaled it up to many other cities, and they've translated it into other languages, so it's definitely a working process. And about 50% of the recipients of the e-cards do choose to avail themselves of the information provided or go and get checked out, so that's a very good rate, whereas a lot of people would in fact just ignore the answer phone message that says, go and get yourself checked out. Now, although the system relies on patients knowing the electronic contact details of their contacts in order to warn them, the team point out that most of the cases of STIs, well, not necessarily most, but certainly a large number of cases of STIs are occurring amongst people who use the internet to meet new partners. And so, by definition, they already have this information. They already have your email address. And so, with 1 person in 10 affected with chlamydia in certain age groups, and rates increasing by, this is frightening, but rates are increasing by 100% per year in some areas. This initiative really could help to stem the epidemic of things like chlamydia. But let's just hope that nobody starts using it to spread internet viruses instead.
Oh, no, that would be terrible. Yes, good way to stop real viruses. And finally, our last little story here is, here at The Naked Scientist, we are all pretty warm-hearted people, aren't we, I'd say?
I think so, yes.
Very nice. Maybe not Chris, but he's not here, so we can say what we like about him. But now researchers at Yale University have shown that it might actually be down to our choice of drinks rather than our lovely warm personalities. Writing in the latest issue of the journal Science, the researchers have found that people judged others to be more generous and caring if you've just held a warm cup of coffee, but actually you think people aren't so nice if you've just held an iced coffee. And following on from this, they also found that people are more likely to give something to others if you've just held something warm, but more likely to take something if you've held something cold. And to test this, the researchers got some volunteers in, some students, and asked them briefly to hold a cup of warm coffee or a cup of iced coffee. So just, can you just hold this a second? And then the volunteers were then given a packet of information about a person and asked to assess their personality. And the volunteers felt that the person was significantly warmer in personal terms. This person's a nice person, generous, and so if they'd just been holding the hot coffee compared with if they'd just held iced coffee. And then they did some more experiments where volunteers either held hot or cold packs and were told that they could either have a gift certificate for a friend or a gift for themselves. And those who just held a hot pack were actually more likely to ask for a gift certificate for their friends than to ask for something for themselves. So not only does physical warmth make us see other people as warmer, but it actually makes us nicer people. So go and turn the heating up. And this actually ties in, there is some science behind it, because it ties in with recent brain studies that show that hot or cold can trigger activity in parts of your brain called the insular cortex. And this area has been found to be damaged in people who have a borderline personality disorder, meaning that they can't figure out who to trust and they can't cooperate with people. So it probably all ties in with the same area of the brain.
Very interesting. And they didn't drink the drink, so it wasn't that they were just enjoying the buzz of some coffee.
No, you just got to hold it. So go and make me a tea, Ben.
Crikey, very interesting. This week also saw the annual Teslathon held at the Cambridge Museum of Technology. The Teslathon sees enthusiastic amateurs get together to show off their homemade Tesla coils. Now, these are huge, high-voltage devices based on the same principle as an electronic transformer. Now, a transformer works because a current in one circuit, which they call the primary circuit, induces a current of a different size in the secondary circuit. Now, this is actually how mains electricity is scaled down from the high voltage and power lines into the safer 240 voltage that gets into your house. Now, I met up with Eric Woodruff to find out more about what the Teslathon really is.
Teslathon is a group of people who are interested in high-voltage electronics, Tesla coils, and pretty much anything to do with high voltage, high current, static electricity, all sorts of technology-related stuff like that.
So really anything that can make a nice big spark?
That's very much part of it. Some of us try and make the biggest spark possible. Some of us try and do it in more interesting ways. And, of course, we try and push the modern technology to do what something can be done 18th century-wise by Tesla himself.
So how did Tesla's original coils work? They seem a very simple principle.
They are a very simple principle. Effectively, it's a standard transformer with a primary and a secondary. And what Tesla did was he also introduced resonance, so that the primary has an associated capacitance, the secondary has an associated capacitance, and the two synchronise with each other and form a resonant coupling. Very much like a young child pushing somebody on a swing. You can get a very small movement that can be made into a very large movement just by the process of resonant rise or multiplication.
And this enables you to have huge voltages, and this is what gives you these lightning-like forks that seem to be flying across the room behind us.
Well, that's right. I mean, some of the coils start at 240 volts. They quite often cheat and go up to 10,000 volts or so into the primary of the coil. And then, due to resonant rise and the way the Tesla coil is constructed, we'll get 100,000 volts or 200,000 volts from the top. But because it is high-frequency AC, that means that we can then push quite a lot of power into a spark or an arc, which will then grow much longer than 100,000 volts sounds.
And that's why they do seem to be reaching out and fingering their way across the room. There are some really huge sort of forks of lightning across there. Is it actually safe?
No. It's a simple answer. Like most things that are interesting or fun, it isn't safe. You have to be very, very careful. Most of the people in this room have been doing it for many, many years. They know their equipment because they've had to build it from scratch. It's not something you can sort of just go out and buy. There is inherent safety. We all abide by a set of rules for the safe running of these sort of events. People have to stand back from the equipment. The equipment has to be able to be made safe. But obviously there is that inherent danger. Any high voltages, high currents, and unpredictable equipment, you've got to view with a degree of distrust.
And I'd imagine that the element of distrust you have means that you actually have to be fairly reserved in public. So the people who come along to the Teslathon this weekend won't really see the full power of what your devices can do.
They will see a limited amount. There are some things certainly that we wouldn't do in a public environment that we would do in private, because obviously the safety of the public and the people who are watching the Tesla coils here today is absolutely paramount. We don't want to hurt anybody. It would really ruin the enjoyment of the whole event for everybody, you know.
And Cambridge Industrial Museum, where we are today, seems like a very appropriate setting for this. I understand you come back each year to do another Teslathon here. Does it feel like home?
Certainly for me. I mean, I've been doing this for about 7 years now. The actual Teslathon has been here, to my knowledge, for 9 or 10. It's usually on the same weekend every year, which for some reason happens to be Halloween. I don't know whether that's by planning or by accident. But no, we've always been very welcome here, and obviously with the connection to 18th century technology, we seem to fit in very well with the other machines and equipment at the pumping station. And of course we all like to go and have a look round at that sort of technology too.
Distilling the best science. The Naked Scientists.
You are listening to The Naked Scientists with Kat and with Ben.
Now, don't forget that we beam this programme live into Second Life every Sunday from 6 p.m. UK time. Of course, our clocks have changed, so I hope we've still got our Second Life gang in there. That's 10 a.m. Second Life time, usually. There's a great group of avatars there who discuss the science in the show, so it's an excellent opportunity for you to have a good chat with people about the science that we talk about. If you want to go there, sign up for Second Life, visit the Scilands and search for The Naked Scientists. You can drop by our mansion, come and relax on a sun lounger and enjoy the show.
And still to come, we're going to be finding out why beauty is in the eye of the beer holder. Ha-ha. And find out what your dance moves could say about your genes. But first, it's time to find out what Dave has got up his sleeve for Ben in this week's Kitchen Science.
For Kitchen Science this week, Dave has promised me an experiment that will help me see the world from a totally different perspective. He's going to open the doors of perception for me. So, Dave, how are we doing it? Have you brought lots of drugs? Are we going to do transcendental meditation? Yoga, perhaps?
I'm afraid not, Ben. I think possibly completely different perspective is a bit much, but definitely slightly different perspective. Instead of any drugs or meditation, what I've got is these rather fetching goggles.
When you say fetching, Dave, you mean that they're going to make me look like a complete idiot, don't you? That one of the eyes is blocked up with what looks like card, and the other one has a thick wedge of glass on it. Dave, these can't be very good goggles at all.
They're possibly not ideal for everyday life, but they do something quite interesting. Because you've got a prism of glass in front of one of the eyes, the light which hits it will bend, so everything, when you look through it, will appear about 10 degrees to the right of where it should be.
So rather than seeing things from a different perspective, you just mean seeing things from a slightly squiffy angle?
Yeah, pretty much.
But what good is this going to do me? Surely I'll just sort of fumble about and fall over.
We're going to have a look at how well you adapt to this. So to start off with, we need to get a baseline. So I want you to take a ball and throw it at me.
Throw it at you? I'm guessing you don't want me to throw it hard, Dave.
No, just gently from sort of 2 or 3 metres away and see how well you can hit my stomach with it.
So I have a normal baseball here, and you've got a jumper with a logo on the chest. So I'm going to throw it quite gently. I'm about 2 metres away. I'm going to aim for that logo and see what we can do.
Ow!
I'm sorry, Dave. OK, that one hit you square in the chest. So my aim's obviously a little bit out because I was aiming slightly to the right of that. Should I do it again just to make sure?
I think we'll be all right with that. Now we'll put the goggles on you and see how well you do then.
OK, so luckily these goggles happen to fit over my glasses, otherwise that would be a bit unfair on me. I'd go completely blind. Oh, crikey. So now I can only see out of my left eye, and everything's crystal clear, but clearly a little bit squiffy, a bit wonky. So shall I take the ball back, Dave? OK, so now I need to aim again. And once again, I'm aiming for the logo on your top. I'm still the same distance away, and I completely missed. that was a good sort of 2 foot to the right of you. I'm very confused. Can I have the ball back and give it another go? Oh, now I cleared your arm that time, clipped you, but only just. But still, that was nowhere near where I wanted it to go. What's going on?
Well, obviously you're seeing me to the right of where I actually am. So you're aiming for where you think I am, not where I actually am. So you're throwing the ball in completely the wrong place. Now, what I want you to do is have a practice over the next few minutes and keep throwing it at me, or possibly I'll try and catch it. And we'll see how you change the way you throw.
OK, so if I could get that ball back, I'll just keep practising throwing, and I'm sure eventually I'll be able to hit Dave properly. And we will come back to you later on in the show to let you know how I've been getting on.
Oh, poor old Dave, having things thrown at him in the name of science. We will find out why Ben had to wear the silly goggles later on in the show. But if you do have any questions or comments, if you've had any experience with bizarre glasses, we would love to hear from you. Our email address is chris@thenakedscientist.com. And now it's time to put on your dancing shoes, because it seems that the way that you dance could say something about your genetic fitness. In other words, how good your genes might be on to pass on to the next generation. And joining us now to explain a bit more about this is Dr. Peter Lovett from the University of Hertfordshire. Good evening.
Good evening.
Well, Peter, tell us a bit about why is it important to actually study dancing?
Well, because there's a very clear relationship between people's level of testosterone and what's called their genetic quality and the way in which they dance. Now, it's thought to be that dancing might be, as Darwin suggested, some kind of courtship ritual, so that like other birds and other animals, we might display ourselves in a particular way to find a mate which is compatible with us. Now, of course, that's not very, well, it is quite scientific, but it becomes more scientific when you realise that the way in which we move might be determined by both our level of prenatal testosterone and also by our physical symmetry. That is, how physically symmetrical we are in terms of our ears and our fingers and our knees and our ankles and things.
So how does that work then?
Well, 2 earlier studies have shown that they asked men to dance. So they got guys into a lab, they filmed them dancing, and then blurred the images out so you couldn't see anything at all about the physical attributes of the men at all. And then these videos were shown to a large group of women, and women were asked to rate which movements were the most attractive and dominant and masculine. And what they found is that the movements of men who had high levels of prenatal testosterone, or men who had higher levels of physical symmetry, were rated as more attractive, more dominant, and more masculine than the dances of the opposite men.
Does this mean that some people then are basically born dancers?
Well, what it suggested, according to the original researchers, was that the testosterone has an organising effect on body movement. So men don't even know that they're high or low testosterone men, but it influences how they move. So it might influence their level of coordination in terms of their movements, or might influence their natural rhythm and how the different parts of the bodies move together.
We know there's loads of programmes on TV here at the moment that are, Strictly Come Dancing and Tap Dance Your Way to Success or whatever they're called. Can people actually really learn to dance well, or is there always going to be this genetic barrier to it?
Well, I think that people can learn. I think they really can learn. Now, it might well be the case that your genetic makeup might predetermine the range of your dancing ability. So it might organise you to suggest that you're more rhythmic, or you might use more complex movements. But of course, then we can teach people then a different, wider range of movements, or a set of movements that might make them appear more dominant or more attractive.
Well, we're going to try this experiment live now. Are you ready for this, Peter?
I certainly am.
Because we have our dancing monkey here. We have Ben Valsler, who's going to do some dancing.
I am more than happy to dance. Yes, Peter, I know that at the moment you are running a survey online, and I've watched your video about the different styles of dancing, and you want people to let you know, sort of classify their dancing and let you know how they dance.
Yeah.
Now, we will put a link to this from thenakedscientist.com so people that listen to the show can join in. But I think it's only fair that, seeing as Kat hasn't seen the video, that I demonstrate for her in the studio.
I cannot wait.
So, Peter, please could you describe to Kat the sort of movements that we're looking for, and I will do the movements for you.
So run the music.
Okay.
Here we go.
Well, the first set of movements is to just step from one foot to the next foot. So you're stepping right and touching left,
Right,
and
left.
stepping left and touching. It's a normal kind of disco move that you see at disco.
Yeah, it's what I did at school. Yeah.
Exactly. Now, keep that quite small.
Quite
and
small, yeah.
Keep the top half of the body doing the same as the bottom half of the body. Now,
This looks brilliant.
but that is the most unattractive dance that men could do.
You're telling me.
Now, what you can do now, if you keep doing that same thing with your feet, but do something different with your shoulders. Roll your shoulders backwards slightly and move your arms up and move your elbows around a little bit.
So Ben's now doing kind of a dancing like your dad kind of dance.
Ooh, well, that could be bad. But as long as the top half is doing something different to the bottom half, and he's in time with the music and there's some rhythm going on.
It's looking like that, yeah.
Yeah. Now, if there's rhythm going on and he's coordinated, then that would be a lot more attractive to women, apparently. Now, if the top half of his body was a bit more random, then it wouldn't be quite so attractive. So
yeah, he's doing some very random things with his arms, over the head, swimming motions.
Now, that's interesting. If he's doing all that might be a bit too big, you see, because the bigger the movements are, the more dominant they're seen by people. Now, they're okay if they're large movements, but they're nicely coordinated movements and unthreatening, then they could be seen to be quite attractive and quite masculine. If they get too big and too random movements, then those ones are seen as highly dominant but highly unattractive.
So we've got the hands waving over the head now, sort of windmill style.
Yeah, he's not going to attract their mates that way, I'm afraid.
I'm taking up most of the studio, I think.
I really wish the webcam was working. This was great. Are there any other moves we can try and get Ben to do, or is that the repertoire?
Make the side-to-siders a bit bigger. So now there's steps, you've got quite small steps, but make them bigger. So step about 1 metre from side to side.
Yeah, it's like the Hulk dancing
exactly,
here.
Yeah. And now get the arms really swinging out wide.
It's like he's doing aerobics.
That's right, a bit like a star jump.
Yeah.
Yeah. Now that again is what he's doing now is making his movements a lot more dominant.
It's not attractive.
It's not, is it?
No.
Now, it's interesting you say that, because some women do find it attractive, and the ones who do are the younger women. So women sort of 16 to 18, 19-year-olds often find those movements quite attractive.
So for any of our teenage listeners out there, Ben is now the man of your dreams.
He might well be, because he might be now. Obviously, it's a bit too stylised at the moment. What he needs to do is put a bit more randomness into it.
More randomness? Yeah, that's fair. Ooh, he's doing waving with his arms now.
Get him to think about being a hip-hop dancer.
Be a hip-hop dancer, Ben.
Kind of big hip-hop dancing.
Yeah, he's got some hip-hop moves, a bit of arm crossing. Are you doing a little sign with your hands there? Yeah, he's doing some hand signs.
Now, all those movements are making him much more obvious on the dance floor. So as you're seeing those movements, you're much more likely to see him. And as long as he's not too threatening, the younger girls would go for those kind of moves.
They'd be impressed with the hip-hop moves.
They would be.
There you go, Ben. Next time you're down the teenage disco. The final thing I'd really like to know is, all your studies seem to have focused on men dancing, and in my experience, men don't dance that well. Is this really true that are girls better dancers than men? Is there any truth in that?
The reason, actually, what we've done, we've just, on the survey we've got online at the moment, what we're finding is that women are rating themselves as much better dancers than men.
Of course.
So they've got to self-rate. But the problem is so many girls have had some kind of formal dance training, even if it's only a few years in jazz, tap or ballet when they're much younger, whereas men often don't have formal dance training. And so when we're looking at the dance, that kind of natural dance, the real sort of dance that's coming out of their genes, it's easier to spot that in men because they're less contaminated by training.
So men could be naturally more proficient dancers.
Yeah, now a lot of
men,
they're very good actually, a lot of them. As long as they relax a little bit more, that you really see some fantastic moves in men. Even if they're not sort of formally recognisable moves, you really see some great rhythm happening in men.
Are you much of a dancer yourself as well?
Well, I was a professional dancer before I became a psychologist.
What's your favourite type of dance?
Oh, well, now I don't know. Also, I do everything. I do jazz, tap, ballet, ballroom, contemporary, everything I can do. I love to dance. Dancing is wonderful. Absolutely
fantastic. And so your videos are going to be available on the Naked Scientist website. And how long are you conducting this experiment for?
Well, we want it to go for as long as we possibly can, really. What we're doing, the survey at the moment, we want to find out how good people think they are at dancing, and then we want to find out what sort of movements are best characterised by their dancing. What we found is that men under the age of 25, their level of testosterone predicts how good a dancer they will say they are. So high testosterone men say they're good dancers, low testosterone men are bad dancers. In the over 25s, the pattern goes away. But the men are still very good. We want to know what sort of movements men are using at all different ages through their life.
So whether you're sort of a hip-hop person or a bit of a big box, small box kind of person.
Exactly, or just a completely untrained, just bopping around at a disco
flailing
type of person. Yeah.
That's absolutely fascinating. So thank you very much. That's Peter Lovett from the University of Hertfordshire. Thank you.
Thank you.
From protons to photons and gluons to muons, The Naked Scientists. Science that's fundamentally more fun.
Now, can you trust your memory? It seems that a large proportion of people, when they are asked, can actually remember seeing things that they have never had the chance to see, unlike Kat Arney, who's just seen something she never had the chance to see before.
I'm never forgetting that, I tell you.
Which was me dancing like an idiot. Now, but the things that people do recall include things like footage of the London bus bombings that have never actually been shown. They imagine and really remember that they've seen this, even though they never have. Now, the unreliability of memory is something that we should be worried about in a legal setting, but actually more damaging to our health are the memories that we just cannot forget, like watching me dance in the studio, but more importantly, like the debilitating flashbacks occurred by sufferers of post-traumatic stress disorder, or PTSD. Memories in Distress was a recent talk given by Peter Naish from the Open University. Before the talk, he explained to Meera Senthilingam how, in PTSD, the brain can be fooled into accepting a memory as if it were happening in front of your eyes. This is definitely both a distressing memory and your memory in distress.
The event is covering a whole spectrum of memory problems. These problems seem to be associated with processes that make people very unhappy sometimes. This can be the fact that when people tend to be a bit depressed anyway, they seem only able to remember sad events from their life and all the good times fade into the background. An even worse thing to put up with is post-traumatic stress disorder, when people get terrible flashbacks of some shocking event in which they took part, like a road traffic accident. I'll be telling the story of someone who was trapped on one of the underground trains when the terrorist bombs went off. And afterwards, for a long time, she got vivid flashbacks, so vivid she felt she was still there on the train. And she believed that the flashbacks, which only lasted a short while, that they were real life and that she was still in the train and was going to die. Really a horrible experience that went on for months.
What happens in someone like that's brains in order for them to actually believe that the dreams that they're having are reality?
We have to go back and consider how memory works. The brain really is an information processing system. So all the information that our senses acquire about our world, they have to be analysed so that we can make sense of it. And The brain has specialised areas, some that deal with visual processing, some for sound, and even within those there are subdivisions to do different tasks. And finally, you, as it were, put it all together and you have your impression of what is going on around you. As the information goes through the brain, it leaves a trace, and that trace is a memory. Now, because it's all distributed, you have to have a process that can assemble things. And this seems to revolve around a part of the brain called the hippocampus. It's the part of the brain that gets bigger in London taxi drivers when they learn the entire London A to Z. So wherever you ask them to take you, they know it just like that. It's a prodigious memory feat, and their brain actually gets bigger as a result. So the hippocampus gathers together the relevant little pieces of information for the particular memory you're trying to resurrect. But there seems to be another system which one imagines must be the more primitive one. When memory got underway for animals, it must have been a thing for safety. If you have a scary experience and your brain is designed to recognise that it's dangerous and so you run, the next good thing to do would be to remember that, so that in future, if some of those scary things start to show up, it triggers exactly the same response. In other words, you feel frightened, even if you don't actually see anything dangerous yet. And that is looked after by another part of the brain, not the hippocampus. There's a region called the amygdala. And it would seem that when people get post-traumatic stress disorder, PTSD is called, it looks as if the amygdala has taken over. So it's almost like having a library. All the books are our little details, and we assemble the necessary books to get the complete story. That can be done with a good, well-ordered librarian, the hippocampus, or there's this maniac who just keeps dashing in and getting the books and shoving them under your nose. You've got to read them, and that is PTSD.
So you're saying that when someone is taken back to distressing times, the amygdala essentially is pushing out their happier memories from their hippocampus and just placing these worse memories in, and that's what they're experiencing.
I think the amygdala is principally involved. The story I was just telling is particularly for post-traumatic stress disorder, which is far worse than simply being depressed, although that's bad enough. The amygdala seems to be involved when the memory just will not go away. The slightest thing can trigger it. The lady I mentioned who suffered in the tube bombings, she dreads firework night. She hears an explosion and there's nothing she can do about it. The memory is there in front of her eyes as if she's back on that train. Whereas other things will jog your memory. Someone says something, or you perhaps have a smell that you remember and you think, oh, that takes me all the way back to whatever. But you don't then have to keep thinking about it. And although it takes you back, it doesn't make you think you're there. But the amygdala seems very much to collect all the raw sensory information coming in before it's well processed. It makes something that looks just like it would have done if information really were coming in. The poor brain, a bit further downstream, doesn't know the difference. It gets information that seems to be coming from the senses, and it treats it as real.
So now that you know this about what's happening in the brain, what is the research being done in order to help people that are having, say, recurring nightmares or post-traumatic stress?
We are getting better and better. We have someone speaking here today, Professor Anke Ehlers, together with her colleagues, her husband, Professor Clark. They have developed a very nice program for PTSD, which gently has to take people back in their mind to these, they call them hotspots, the key things that just keep coming back into their mind. And little by little, the sting is taken out of it, as it were, and it lets the information be processed really in the proper way. It looks as if it's letting the hippocampus do its normal job, and that takes over and turns it into a more well-behaved memory that will sit on the library shelf until anyone wants it. And, of course, these poor people aren't going to want it in a hurry.
That's a promising and surprisingly simple way to tackle post-traumatic stress disorder and let people who've been through disaster return to a normal life. Peter Naish there, talking to our very own Meera Senthilingam.
Lifting the lab coat on the world's best science. The Naked Scientists.
Now, who in this studio has had the old beer goggles on? Yeah, when, you sort of had a few, maybe, a sweet sherry or two, and you suddenly think that across the room is the man of your dreams, and it turns out he's some kind of terrible four-eyed ogre or something like that. Horrible. Well, it's a well-known phenomenon, and it does lead people to do things that they regret. And now psychologists at Bristol University have been looking into this, and it seems there's more to it than first meets the eye. And now here we've got Marcus Minafo to explain it a bit more. Hello, Marcus.
Hi.
Hello. So how does this all work? Do beer goggles really exist, and what causes them?
Well, they do seem to exist, and that's probably not a great surprise to most people. As you say, many of us have been in that situation where we've had a drink and found ourselves finding other people attractive that perhaps before the drink we didn't. This started out really as almost as a bit of fun as a student project, because we were surprised that no one had actually tried to do this in the more controlled environment of a lab. So although it was a popularly understood or believed phenomenon, no one had tried to look at this under controlled conditions. So we did, and we randomly gave people either a drink containing alcohol or a placebo drink that tasted and smelt the same but didn't contain alcohol. And we found that after a relatively small amount, equivalent to 1.5 pints of beer or a large glass of wine, people rated other faces as about 10% more attractive. These were faces of male and female participants who were presented on a computer screen, and people just had to rate them on a 7-point scale for how attractive they found them.
And it's definitely the alcohol. Is there a placebo effect in here at all?
Well, we didn't compare the placebo drink with nothing, so there may have been a placebo effect which we didn't detect. But certainly when we compared the placebo condition to the alcohol condition, there was this 10% difference. And what was interesting was that it didn't seem to be restricted to opposite-sex faces. So we, for that reason, explicitly recruited people who described themselves as heterosexual, and even same-sex faces were rated as equally more attractive as opposite-sex faces.
So you just think everything looks great?
Well, pretty much. At least that's what the data look like. And so what we want to follow this up with is to see to what extent the effect is specific to faces. People weren't, because we gave a relatively small amount of alcohol, people weren't saying that they were happier or they weren't reporting any changes in their mood, but they were rating faces as more attractive. So there is a question of whether or not we would rate anything as more attractive.
Like art or something like that?
Like art, like landscapes, things that you could meaningfully describe as attractive might show the same effect. And so we're running a follow-up study to look at this now. But the interesting thing is that this seems to be, potentially at least, and we need to do a few more studies to fine-tune what we think is going on, if you like. It seems to be quite a general effect of alcohol on potentially processing of faces, but potentially processing of anything that we could think of as attractive. But there was one study which looked at this in a more naturalistic environment where they went into a bar. Now, they didn't control for what people had been drinking. They didn't randomly give people one drink or another. So it was a less controlled experiment, but it was conducted in a real-world environment, if you like. And they just asked people how much they'd been drinking and then got them to do something similar to what we did. And in that situation, then the effect was specific to opposite-sex faces. So what we think might be happening is that there's one effect of alcohol, which is that it modifies how we process faces, attractiveness, and so on. And then when that occurs in a particular social setting, where there are social cues to do with, if you like, mate-seeking behaviour and social interaction and so on, then that effect becomes targeted at opposite-sex faces.
And now, if you're at a typical party, it's not just booze that's there. There may be cigarettes. If you're at a very exciting party, there may be things like drugs. Do these have an effect on attractiveness as well?
Well, this is where it becomes a little bit more interesting. So finding this effect for alcohol is straightforward enough. Alcohol is an important drug in much of the Western world and is largely used in social situations. The exact nature of those social situations differs across different countries. But you're right, there are plenty of other drugs that we use, including legal ones, very commonly. Caffeine is one, nicotine's another one, and there are other drugs which are not legal in this country at least, which are also used fairly extensively. We looked at nicotine, and we did basically exactly the same study, which was not an easy study to do because, of course, it's illegal to smoke indoors now. And
bad luck.
which there is an exemption in the legislation for research, but for this study we actually had to do it in the back of a pub, which was a more realistic environment. So we were sat there with a laptop and these quite clever cigarettes, which either do or don't contain nicotine. So you smoke a cigarette and you don't know whether or not it actually contains nicotine. So essentially, you have a placebo condition and a nicotine condition. And what we found was exactly the same effect for nicotine. Now, these were very light smokers, but again, after one cigarette, there was a marked increase in the ratings of attractiveness of faces when the cigarette contained nicotine compared to when it didn't.
That's really intriguing. Do you know why this might be? Do you think certain pathways in the brain are similarly being activated here?
Well, we know that drugs of abuse have the capacity to stimulate the reward system and the dopamine pathway in a part of the brain called the nucleus accumbens, and that might be part of the reason. Nicotine's an interesting case in point, though, because we know quite a lot about why nicotine's addictive. And one of the reasons it's addictive, nicotine's not a drug that gives you a very powerful psychoactive effect in the same way that, say, alcohol does or cocaine or heroin. Once you've had your first 2 or 3 cigarettes, you kind of tolerate the strong response that you get to those. And after that, the effect is relatively mild. But what nicotine seems to do, and there are animal studies which show this using different kinds of experiments, obviously not attractiveness, is that they make everything else that happens around you slightly more reinforcing. So in technical language, if you like, it non-contingently enhances or potentiates the reward value of other things that are happening at the same time.
And in another thing that you sometimes associate alcohol with is not necessarily being attracted to someone, but actually beating them up. If you're being more attracted to people, why does alcohol also fuel violence?
Well, there are lots of social cues that are present in faces, and it's not necessarily the case that alcohol is going to be having uniform effect across all of those different facial cues. So one of the things that we get from faces are judgments of attractiveness. In other words, if we think that they might be a potential mate, then we would direct our attention towards one sort of person over another, for example. But we also get information about what kind of emotion that person is expressing, whether they're looking at us, whether they are a potential threat. And so there are lots of different cognitive mechanisms and information which is expressed in faces which we can interpret, and alcohol may modify the interpretation of those different pieces of information in slightly different ways. And so we have a program of studies that's looking at this, looking at, for example, judgments of eye gaze and whether or not people are perceived to be looking at us after we've had a drink compared to when we haven't had a drink.
That kind of, are you looking at me? That kind of
thing.
Well,
exactly that. And people certainly do start to see the world in a different way after they've consumed drugs, and we're seeing this for nicotine and alcohol, which are the 2 ones we mainly investigate. And there are quite complex and quite subtle effects which we can reproduce in the lab, but which in the real world probably interact with all kinds of social cues and with the more general disinhibiting effects of alcohol as well.
Absolutely fascinating. Well, that'll keep you busy for a while. And that's Marcus Manafo from the University of Bristol. So thank you very much for joining us on the show, Marcus.
Thank you.
Keeping you abreast of the world's best science, The Naked Scientists.
And now it's time to invite the beautiful Diana O'Carroll back to the studio for our question of the week. Hi, Diana. I saw you enjoying my dancing just then.
Yes, it was equally as attractive. Anyway, here's something else that's really attractive. It's putting on bicycle clips for the following question.
Hi, this is Bunny calling from Portland, Oregon in the States. On a recent trip from the farmer's market with a heavy load of fruit in my bike basket, I started to wonder if the placement of the load on the bike makes any difference in the efficiency of the work I do. Would it be easier for me to have baskets on the back where I would pull the load as opposed to on the front where I must push my load? Or is it simply too small of a system to make a difference?
So, is there really a proper way to load your bike?
My name's Josh Starling, and I'm a lecturer at the University of Bath. And the question is, what's the best way to load a bike? Well, tricky really. The answer is pretty much however you want to do it. If you're looking at just the rolling resistance, the way tyres work is that the more weight on the tyre, the more the rolling resistance. What I mean by rolling resistance is how difficult it is to push the wheel forward against the road. So as long as you keep the pressure in the tyres at a nice high value, you'll find that they roll very easily. So whether you're going to put the weight on the front or on the back, given that it's got to be shared by one or the other, it's not really going to make that much odds. That's the sort of simple answer, but of course it's never quite that simple, because if you look at the finer detail, you've got more complicated things like aerodynamics. So if you've got a basket on the front, that's probably not going to help a whole lot, and you might do better to put the luggage on the back where it's hidden behind the rider. The other thing that you might find is that if you've got all the weight over the front, then the front gets a bit wobbly. So rather than cycling in a nice straight line, you're going to be wiggling a bit and trying to balance the bike more carefully. And in a way, that's going to waste some of your energy. It's a bit like scrubbing off the speed if you're trying to go round a bend quickly. So in a sense, you do better to try and share the weight between the front and the back. So the answer is, it's not going to make much difference at the end of the day. And unless Bunny is whizzing down hills at enormous speed in Portland, I suspect the aerodynamics aren't going to be a big issue. So you needn't worry yourself about where you put the weight.
So loading your shopping won't make your work more efficient in any particular way, but it turns out that it can have an effect on your steering the closer it is to your centre of gravity. There are some fantastic diagrams drawn by listeners on our forum to demonstrate this, but time is getting on, so I shall move on to our next question of the week.
Hi, this is Jared from Logan, Utah in the United States of America. I've noticed that as I've grown older that time feels like it's moving faster than while I was growing up. Is there any reason for this, and what is it? Thanks. Love the show.
So, why do the years seem to slip by the more wrinkles we gain? Let us know what you think by emailing chris@thenakedscientist.com or by putting it on our forum where you can now draw your thoughts. You can find it at thenakedscientist.com/forum.
Bringing the facts to bear. The Naked Scientists.
You are listening to The Naked Scientists with Dr. Cap and with Ben. And earlier on, Dave was using himself as a rather fantastic human target for Ben to throw things at. So while Ben was modelling some rather fetching goggles that shift what his eyes can see 10 degrees to the right, let's find out how Dave got on with it.
Well, welcome back to Kitchen Science. Ben's been practising throwing a baseball at my chest, wearing a pair of goggles which moves his vision about 10 degrees to the right. So let's go and see how he's been getting on.
Okay, so for the last sort of 20 minutes or so, I've been wearing these god-awful goggles that make me look an absolute idiot, I'm sure, and I've been throwing the ball at Dave's chest. Now, generally now, with my right arm, when I aim for Dave's chest, I can hit it, although when I started out, I was throwing it a long way to the side of him. So, obviously, I'm getting used to being able to do this. What's going on in my brain, though, Dave? Why can my arm get used to seeing things that aren't really there?
Well, there's part of your brain called the cerebellum, which takes instructions from the rest of your brain and converts them into action instructions for your nerves, which control your muscles. And this spends its whole time learning. So if you do something and you get it wrong, it thinks, I shouldn't have done quite that. Maybe I'll try something slightly different. And it slowly adjusts and gets you better and better at doing things, which is why practice makes perfect.
So even though what my eyes see isn't really where things are, all I've been doing is practicing throwing in the right place, and my cerebellum has learnt that this is the right way to throw to hit the target I'm aiming at.
Yeah, that's right. So if you try throwing at my chest with your right arm, which you've been using, hopefully you should be quite good.
Okay, I'll give it one more go now then. So I'm going to aim for your chest, and with my right arm, perfect. That hit you exactly where I was aiming for.
Yeah, that's right. You're obviously learning quite well. Now, if instead of using your right arm, you try using your left arm, which you haven't been practicing with.
Okay, right. Well, once again, I'm going to aim for Dave's chest. I'm not brilliant at throwing with my left arm anyway. My aim certainly isn't as good. And that sailed past you. That was almost exactly as it was when I first tried with my right arm after putting these goggles on. It was clearly a long way next to where I was aiming. So why hasn't my brain got used to seeing the world from a different angle?
Well, your brain hasn't learnt to see the world from a different perspective. It's just learnt how to throw with your right arm to hit me in the chest. If you then try it with your left arm, you haven't learnt how to do that yet, so you're still rubbish.
So the part of my brain that tells my right arm where to throw has learnt how to accommodate for this change in my vision. But the part of my brain that controls my left arm hasn't had to learn that, and that's why I now can't aim at you at all with my left arm. But actually with my right arm, I'm quite accurate now. Why is it then that, say, with short-sightedness, why doesn't your brain learn that your muscles need to work that bit harder to focus and therefore pull your lens to the right shape and fix short-sightedness when you're young?
Well, it depends how much work the muscles have got to do to make the correction. If you're a little bit long-sighted or a little bit short-sighted, then your eyes can adjust and you will just possibly get a headache, which is often the first thing which gives it away that you've got something wrong with your eyes. However, if you're very long-sighted or very short-sighted, there's just no way your muscles are strong enough, so they can't adapt, so you've got to wear glasses.
Fascinating. Well, talking of glasses, am I allowed to take these goggles off now?
Yeah, go for it, and we'll see what that learning's done to your throwing with them off.
Okay, so I'll take them off, but as one of them's blocking my eye so I can't see at all, I'll leave that one on so I can only see out of my left eye. Oh, you're really not where I thought you were. I haven't been facing you for the last half an hour. Okay, so what did you want me to do now?
Okay, now try throwing it at me with your right arm.
This should be easy. I can see as per normal now, with my right arm aimed to your chest. I'm quite disturbed because that was clearly a metre off to the side. That I can't aim correctly with this arm anymore. Have I broken myself permanently, Dave? Am I never going to be able to aim again?
Well, it possibly depends how well you could aim in the first place. But no, you should be able to learn how to do it the right way again. Now you don't have this distortion. If you try it with your left hand, for example, it shouldn't have any effect.
So this is throwing with my left hand, which had never trained to take the goggles into account. And that was why I couldn't throw very well with my left hand with the goggles on. So now with them off again I'm aiming for your chest, and it hit you square on. So right now I can only aim with my left arm and not with my right. How long is this going to last?
We should be able to train yourself to throw properly in about the same amount of time as you took to train yourself with the prism on your face.
Okay, well, clearly my arms are out of sync right now, so I'm going to practice throwing with my right arm until I'm confident that I can throw at least as well as I could before we started. But that's all for Kitchen Science this week, and Dave will be live in the studio with another exciting Kitchen Science next week.
So your brain has to adapt to doing things based on what you see, and this is all controlled by something called the cerebellum. That's Latin for little brain. The cerebellum's about the size of a fist, and it sits below and at the back of your brain, and it allows you to learn movements like throwing by comparing what you wanted to happen with what actually happened. And if the two don't match up, then your cerebellum kind of adjusts the strength of the nerve connections in the circuits in your brain to tweak that movement. So next time you do it a bit better, and this is called long-term potentiation, and it's basically how we learn how to do physical stuff, and it's absolutely fundamental to most complex animals' behaviours. But Ben, did you learn to throw properly again?
Well, eventually, yes, I did, but it is a very, very strange experience because it feels like your muscles are just rebelling against what you tell them to do. You tell them to do one thing, they seem to do something completely different. Now, we have put a video of me relearning how to throw, so you can see Dave getting repeatedly wounded by me throwing balls at, or at least near him. And we've put this video on the website at thenakedscientist.com/kitchenscience, so you can see how long it takes me to adjust and how silly I looked in the goggles. And of course, there's lots more experiments for you to try out at home, all on our website at thenakedscientist.com/kitchenscience.
Fantastic. Well, that's all we've got time for this week. It's been a really fascinating show, especially the dancing. And I'd say a big thanks to all our guests. That's Derek Woodruff, Marcus Minafo, Peter Naish and Peter Lovett. I'd like to thank the production team, Diana O'Carroll, Mira Senthillingham and Tom Simpkins here, who's been doing all the knobs and twiddlers and faders in the absence of Chris. Next week is a question and answer show, so get your questions in now to chris@thenakedscientist.com. We'll have the answers for you, along with the latest news on what's hot and what's not in the world of science, live Kitchen Science, and you can hear the show again, catch up with shows you've missed, and the Naked Scientist podcast, www.nakedscientist.com.
The Naked Scientist podcast comes to you from Cambridge University and is supported by the Wellcome Trust, the EPSRC and UK FAST. For more information, look us up online at nakedscientist.com.